Hi, and welcome to another tutorial video. In this tutorial video I'm going to be going through the factors that affect the performance of a CPU. And the factors that you need to know about are as follows. So the clock speed, core count, cache size, and cache type. So first of all then I'm going to take a look at the clock speed and how that affects the performance of a CPU. So the clock speed of a processor determines how many instructions can be executed per second. So for example, a processor core operating at a speed of 3 GHz would be able to execute 3 billion instructions per second. So increasing the clock speed increases the number of instructions the processor can execute per second. So the clock speed determines how many instructions can be executed by a CPU core every second. So that impacts on the CPU's performance, because if you increase the clock speed, it increases the number of instructions that a CPU core can execute per second. Now let's take a look at the core count, so the number of cores that the CPU has. How does that impact on the performance of the CPU? Well, the number of cores that a processor has determines how many instructions that it can execute simultaneously. So a single CPU core can only execute one instruction at a time, and if you add more processor cores to a CPU, it's able to execute more than one instruction at a time. So the number of cores determines the number of instructions that a CPU can execute at the same time. So for example, a quad-core CPU can execute 4 instructions at the same time because it's got 4 cores, whereas a hex-core CPU can execute 6 instructions at the same time because it's got 6 cores. So now let's take a look at cache size. So cache is a special type of memory which is much faster than RAM. So RAM with main memory, so it's much faster than your main memory in your computer. And small amounts of cache memory are usually built into CPUs, and cache is used to store instructions that are most frequently used by the processor, and the processor can fetch the instructions that are stored in cache much faster than those stored in RAM, and thus they can finish the fetch, decode, execute cycle much faster if an instruction is stored in cache, because it can do the fetch part much faster. So how does this cache size impact on CPU performance? Well, the more cache a computer system has, the more instructions can be stored in the cache, and therefore the faster the CPU can execute a given set of instructions, because a greater proportion of the instructions will be stored in the cache, and a greater proportion of those instructions, the ones that are stored in the cache, can be fetched more quickly. So the final factor then that you have to be able to consider is the cache type. And not all cache is created equal. Cache comes in different levels. Most CPUs will have level 1 to 3 cache built in, and that's the most common. A few CPUs will have level 4 cache, but that's quite uncommon. So most CPUs just have level 1 to level 3 cache nowadays. And level 1 cache is the fastest and closest to the CPU core. And usually only very small amounts of level 1 cache are present in even today's computers. So for example, my laptop only has 64 kilobytes of level 1 cache. Level 2 sits in the middle, so it's faster than level 3 cache, but slower than level 1 cache, and slightly further away from the CPU than level 1 cache, but closer to than level 3 cache. And more is available usually than level 1 cache. So my laptop, for example, has 256 kilobytes of level 1 cache, so more than the 64 kilobytes of level 1 cache that it has available. So level 2 cache is faster than level 1 cache, but slower than level 3 cache, and closer to the CPU core than level 3 cache, but further than level 1 cache. And level 3 cache is the slowest of all the cache levels commonly used in today's processors. It's further away from the CPU cores than level 1 or 2, but larger still. So for example, my laptop has 3072 kilobytes of level 3 cache. So the analogy that I would use to sort of think about this is to imagine a desk with a shelf behind it and a filing cabinet to the side. The papers that are stored in the desk are level 1 cache, so the papers stored on the desk are level 1 cache. It's fastest to search for what you're looking for, but there's the least room on the desk. The papers stored on the shelf behind take slightly longer to search, but there's more space to store stuff. And the papers stored in the filing cabinet take the longest to search, but there's the most room out of the 3 locations to store files. So that's just one way of thinking about how the different levels of cache are different to each other. But you might be asking yourself, how does this affect the performance of my CPU? So the amount of cache you have for each different level affects the speed at which the CPU can fetch instructions. So if you have much more level 1 cache than a different processor, then more instructions can be stored in this in the fastest level of cache and can be fetched more quickly. So the different levels of cache and how much cache you have at each different level affects how quickly instructions can be fetched from cache memory. Okay, so that brings us to the end of this tutorial video on the factors that affect the performance of a CPU. So just a quick reminder then, the factors that you need to know about are clock speed, core count, cache size, and cache type. So I hope you found that video useful, and thanks for watching.